multiplying and dividing complex numbers. First, we're going to look at multiplying complex numbers. 4 plus 3i times 5 minus 2i. And then we're going to look at dividing them. 4 plus 3i divided by 5 minus 2i. But first, let's look at multiplying. What we're going to do here is you can essentially do this as two binomials being multiplied. You can do FOIL. Right? You can multiply the two first terms together. 4 times 5, that gives you 20. And then you can do the outer, 4 times this minus 2i. Positive times a negative is negative, so this is going to be minus 8i. And then you're going to do the inner, 3i times 5 is 15i. So we have a plus 15i. And then you're going to do the last two terms multiplied, 3i times this negative 2i. Now I times I is I squared, and 3 times 2 is 6. So this is going to be a minus 6i squared. Now what you want to do is you want to simplify this down into standard form of a complex number, where you have a real part and an imaginary part, a plus bi. These two inner terms, they're like terms, we can combine those. Negative 8 plus 15 is 7, so we have 7i. And I squared is negative 1. Because I is square root of negative 1. That's the definition for I. So if you square both sides, you see I squared. The square will get rid of the square root, and you have negative 1. So to get rid of the I squared, we're just going to replace it with negative 1. So we have minus 6 times negative 1. So that's really a plus 6 at the end there. So we have 20 plus 7i plus 6. And then you want to combine the 20 and the 6 together. So the answer here comes out to 26 plus 7i. That's the answer to the first one. That is multiplying two complex numbers together. And you can see we end up with a complex number here, where the real part is 26 and the imaginary part is 7i. So yeah, whenever you're doing these problems and you run into I squared, you simply replace it with negative 1. All right, let's look at dividing them. Now this is division. We got 4 plus 3i divided by 5 minus 2i. Now to do this one, what we're going to do is we're going to take the bottom piece and we're going to change the middle sign on it to create the conjugate of the denominator here. And then what we're going to do is we're going to take that conjugate and multiply top and bottom of the fraction by it. So the conjugate of 5 minus 2i would simply be 5 plus 2i. So what we're going to do is we're going to multiply top and bottom by 5 plus 2i. And what happens is when you multiply two conjugate pairs that are complex, you end up with a real number, which is what we want to hear. We don't want to divide by anything with an I in it. All right, so maybe parentheses will help you out here. So you can see essentially the top and the bottom is multiplying like we did in the first example. So we're going to FOIL the top piece. We got 20. 4 times 5, and then do the outer. 4 times 2i is 8i. Then we have 15i in the middle, and 6i squared for the L in FOIL. And then you can do the same thing on the bottom. We got 5 times 5, 25. The outer, 10i. The inner, minus 10i. And then we have a minus 4i squared. So you can see multiplying two conjugate complex numbers, you see that the middle two terms cancel. That's what happens when you multiply complex conjugate pairs. Now remember, I squared, we're going to replace that with negative 1. So this is really 6 times negative 1, which is going to end up being a minus 6. So up top, we have 20 minus 6, which gives you 14. For the real part. And then 8i plus 15i gives you 23i. Now on the bottom here, we got 25 minus 4i squared. This I squared is again -1. So we have more minus 4 times -1, which double negative multiply turns into a plus 4. So on the bottom, we really have 25 plus 4, which is 29. Now what you want to do to finish it is to take the 29 and split it up. So we're going to end up with 14 over 29 plus 23 over 29. The reason for splitting it up is so that you can see clearly what the real part is, 14 over 29, and what the imaginary part is, 23 over 29. Make sure the fractions are simplified. It looks like they are, so that is going to be the answer to the second one. There you go.